Our next lesson deals with the stoichiometry of solutions. And you're going to see again that it's very much similar to what we've done before. So we've just got a couple of practice questions, and then also I want to show you how to start doing them in one running step. Some of you will find this uncomfortable to do, and you can continue doing it step by step. But for some others of you, you're ready to the point of putting this all together. And you're going to see that when you finally learn how to do that, it speeds up the questions and also makes you less prone to error because you're not writing down numbers over and over again. So it says, what is the concentration of sulfuric acid if 45 mils are required to neutralize 20 mils of a 0.1 mole per liter solution of sodium hydroxide? So for this one, I've got a double replacement reaction, neutralization. So I've got H2SO4 plus sodium hydroxide, and I'm producing water. I'm going to keep it as HOH for this equation. You can write it as H2O, and then Na2SO4. So balancing this out, I need to do this, and now it's balanced. So now I'm going to write down the information. I've got 45 mils of H2SO4. I'm going to change that right away, 2 liters. And I want to find out the concentration. So this is what I'm looking for. For my sodium hydroxide, I've got 20 mils. Again, I'm going to change it to liters. And I've got a concentration of 0.1 mole per liter. All right, so by the way, I think this is where it shows the importance of writing your information underneath the appropriate substance. Now I've got 2 volumes, and this really keeps it separate as to what goes together with what. So one big mistake that I get all the time is I get the wrong volume being combined with the wrong concentration. And this really kind of lets you see what belongs together. So I'm going to start then. That's step 1. Step 2 is finding moles. So 0.02 liters. Remember, you always want to start with the number with 1 unit and use your second number as a ratio. And so for this one, it's going to be 0.1 mole per liter. My liters cancel out, and I'm left with 0.002 moles. All right, that's step 2. Step 3 is a mole ratio. So I'm going to start off with 0.002 moles of NaOH. And then my mole ratio, it's 2 moles of NaOH at the bottom and 1 mole of H2SO4. And so this gives me 0.001 moles of H2SO4. And then the last thing, I'm looking for concentration. My concentration is going to be 0.001 mole divided by my volume, so 0.0450 liters. And this turns out to be 0.0222 moles per liter. Now, like I said, I'm going to show you how to do this in one running step. And so for this one, same process. My first step is going to be to find my moles. And so for some reason, we use like brackets for these. You can see that I started doing it at the beginning because my intention was to show you this. You can use just times, but you'll see that we tend to write it these in brackets. So you can see that my first step looks no different than the first step that I did for solving these. Okay, looks no different. And by canceling out my units, you can see that I'm left with moles. So I did step 2 in my stoichiometry. Now, instead of finding the answer, if I'm doing this in one running step, what I'm going to do is I'm going to go directly into my mole ratio. So this was moles of NaOH. So I need my moles of NaOH at the bottom. and my moles of H2SO4 at the top. So there is my running a step, or my mole ratio, that's next. And now I have moles of H2SO4. And then the last step is to find concentration. And remember that constant dividing by a number is the same as 1 over multiplying by 1 over that number. Okay. And when you solve this, you end up with exactly the same answer. And your units are moles. You can see it are moles per liter. All right. Now, we did the same thing. We found moles, right? We then did the mole ratio, and then we solved, but we did it all in one step. And very much like you see everything in brackets here, you just put what's inside the brackets in your calculator and solve it. So you do the one calculation at the very end after you set up your question. And like I said, that does cut down on errors. It also speeds you up because you're not writing down the answer to every intermediate step and kind of rewriting the process, right? So as I always tell students, work towards doing it in one step. For some of you, you will feel comfortable with this. For others, it'll take a little bit of getting used to. I know personally for me it did. It wasn't intuitive, but once I did it, boy, I was glad I did. So please make sure to give this a try with your practice questions. All right, let's do our last question here, and I am going to do it just in one running step. I'm not going to do each individual step. So first step, of course, is balanced equation. So it says what mass of calcium hydroxide is produced when 25 mils of a 0.3 mole per liter solution of potassium hydroxide is mixed with excess calcium nitrate. So for this one here, I've got potassium hydroxide, and it's being combined with calcium nitrate. Again, double replacement reaction, so I get calcium hydroxide plus potassium nitrate. Now, because this is a double replacement reaction, I need to look at the solubility chart. KNO3 is aqueous, CaOH is solid. Okay, not that it matters that you got this because you can still do the information, but just a reminder, right? We've just finished doing that and looking at precipitates and net ionic equations. And so I want you to remember that all this kind of holds as you work your way through it. So I already started balancing. I do that. I have a tendency to balance these as I write them, okay, which is why sometimes I forget to balance them when I teach them. So anyway, there's my balanced equation. And again, I've got 25 mils here. Switch that to liters. My concentration is 0.3 moles per liter. And they want the mass of calcium hydroxide. All right, so I can find the moles of my calcium hydroxide. So 0.0250 liters times 0.3 moles per liter. And that gives me moles of potassium hydroxide. And you can write that if you need to. I find that I don't at this point. I should, but I don't. And now my next step is my mole ratio. So I have 2 moles of KOH at the bottom and 1 mole of CaOH2 at the top. And so my moles of KOH cancel out, and I'm left with moles of calcium hydroxide. And now the next step is the mass. So to find mass, I need molar mass, the grams per mole. And for calcium hydroxide, it's 74.10. Remember, you never need to show me the work for that. So the units are grams per mole. So I want my moles at the bottom so it cancels out. Grams at the top. And so this is 74.10 grams in 1 mole. Okay? So my moles of calcium hydroxide cancel out and I'm left with grams. At this point, I place it all in my calculator, and this turns out to be 0.28 grams of calcium hydroxide is produced. So that's our last grouping, you can say, of stoichiometry type questions that deal with solutions. But you can see, as always, that the steps are the same. They're no different, except that you're using different variables to solve it. And today, the other thing that I introduced to you is the possibility of doing it together in one running step. And I always seem to harp on it and tell you guys to do this, do this, do this. It really, once you get it, it speeds you up so much and it clarifies things and keeps your work neat that students, once they get it, they don't go back. So I hope this made sense and how to put it all together. And again, as usual, a little bit of practice to make sure you feel confident with these calculations.